Hi everyone, welcome back to our new videos where we are discussing design and analysis of algorithm. In our previous videos, we have seen the concepts of space complexity and time complexity, followed with various examples on it, and we have also seen what is efficiency of an algorithm. Now, let's conclude this topic by stating some of the best, or I can say very general and widely used algorithm will state the time complexity, and already we have stated space complexity in our previous video. So let's go through the list and just write them, and in our upcoming videos we are going to discuss about all these algorithms one by one, with their code, with their way of execution, and we are going to figure it out, their time complexity and space complexity. But in this video we are just going to iterate through the list, that what are the time complexity in best, average and worst case. We have already seen what is best case, what is worst case, and what is average case. Best case, if you remember, it is the minimum number of basic operation gets executed for an algorithm. Worst is the maximum number of the things for an basic operations. And space complexity, we have already seen, it's the measure of the auxiliary space plus the fixed space, right? So let's go through this list and we'll see. So if you remember, for selection sort we have space complexity of constant, that is 1. But selection sort also, I have given an example, if you remember that, for our this, what you can say, for time complexity, the best case is n square. Average case also lies in the domain of n square efficiency class, and worst case also lies in the domain of n square. It is big O of n square. Many people still have doubt what is big O, but is omega and all the stuff. We'll take those on asymptotic notations video. So please go and check those videos out. Right now, if we talk about bubble sort, best case efficiency lies in n, average in n square, and worst is also n square. And if you remember, its time complex space complexity, it takes the constant space. Don't worry, it's just a list, we are going to iterate it, but in our upcoming videos we are going to take each of these algorithms and we are going to go in depth of these algorithms. So be with this list. Insertion sort is n square, space complexity is constant. For heap sort, the best case is n log n, because here input gets divided, log n and log n. Understanding? Then for the space complexity, heap sort also takes a constant space of 1 unit, let's say. Quick sort is log n, because there we do n equal to n by 2, we divide input, log n, and worst case it is n square, and here the space complexity is of efficiency class n. Merge sort is n log n in best case, in average case n log n, and even in the worst case it is n log n, and space complexity is n. For bucket sort, it depends upon k, so n plus k, and worst case is at n square, that k becomes instead of addition, and it also takes space complexity of n. For radix sort, it is n times k, n times k, n times k, and here space complexity becomes from the constant factor which we have taken. Count sort becomes the same as of bucket sort, but in worst case it is n plus k itself, and space complexity is just k. Shell sort is also n log n, and n square, and followed by constant space complexity. Tim sort, basically in best it is n, in average it is n log n, and even worst it is n log n, and for space it takes just the n. Then tree sort is, if you see, it is n log n, we'll see n log n, and we'll see this as worst, and it takes a constant. n of space complexity. Cube sort is n log n, and in worst case it goes n log n same and takes n efficiency class of space complexity. So this is the most standard algorithms, or you can say sorting algorithms, and their time complexity in best, average and worst cases, followed with the space complexity. In our next videos, we're going to see each of these algorithms, what is their algorithms, what is their basic operation, and we are going to figure it out all these things. Thank you.